Hi everyone. Now we are going to discuss question 13. Find the value of k such that this piecewise function is continuous at x equals to 2. For this piecewise function, we represent it in an interval where x less than 2 it is kx squared, where x more than 2 which is 2x plus k. The question gives us say that the function is continuous at x equals to 2 by using the definition of continuous. When limit approaches a point must exist means that when limit approaches 2 from the left hand side, which is kx squared, must be equals to the limit approaches 2 from the right hand side, which is 2x plus k, and the limit must be equals to the point where the point is occurring in the function of kx squared, so it will equals to the point of f2 so that the function is continuous. Now we're going to calculate the limit. Substitute 2, it will equals to 4k, and here will become 4 plus k. Finally, k is equals to 4 over 3. Hence, by using this k value, we are going to find the first derivative of a function by using first principles, then determine whether f prime 2 exists or not. Means that determine that is it the function differentiable at x equals to 2. When the x equals to 2, if you want to differentiable at x equals to 2 for the function by using first principle, the limit will x approaches to 2 for the function minus the point of 2 over x minus 2. So the first step, we are going to find what is f2. So f2 is a point where f2 occurred at kx squared, where k is 4 over 3 x squared. So the point of x equals to 2 will equals to 16 over 3. Let us see here, our function is in piecewise function, so left hand side function and right hand side function is different. So when we want to perform the limit when x approaches to 2, we need to calculate one-sided limit, which is approaches 2 from the left hand side and approaches 2 from the right hand side to identify whether this limit exists or not. If the limit exists, means this function can be differentiable at x equals to 2. Then this f prime 2 will be exists. Therefore, the next step, we are going to calculate limit approaches 2 from the left hand side. For the function, we will select here is kx squared minus f2, which is 16 over 3 over x minus 2. Simplify this function. We can factorize x squared minus 4 to become x minus 2, x plus 2. Then we manage to simplify the factor of x minus 2. Then last step, substitute the x equals to 2 here. It will equals to 4 over 3 times 4, which is equals to 16 over 3. This is the first principle which using the idea of limit for x approaches 2 from the left hand side. Now we're going to calculate the limit for x approaches 2 from the right hand side. When x approaches 2 from the right hand side, the function selected will be equals to 2x plus k, where k is 4 over 3. Then minus the point f2 here is 16 over 3. Simplify our function. So the factor of x minus 2 managed to eliminate. When limit for a constant, we will get the answer of constant. So we see here, Limit approaches 2 from the left hand side is answer 16 over 3. Limit approaches 2 from the right hand side is answer of 2. So limit from left hand side and right hand side, they are not same, means that for this first principle where x approaches 2 will not exist. So when this first principle will not exist, means our function is not differentiable at 2. We cannot find the first derivative of the function at x equals to 2. Automatically, f prime 2 will not exist. Therefore, we write our reason here. Therefore, the first principle of this first derivative when x approaches 2 of the function does not exist. So f prime 2 also does not exist.